Hello everyone. Let us solve one question from Jest 2022. A particle moving in a central force field centered at r equal to 0 follows a trajectory given as this. Okay, and this is in r theta, that is the polar coordinate of the particle, and alpha is greater 0. Is a constant. The magnitude of the force is proportional to how much? As the trajectory is given r equal to e power minus alpha theta. So do you know the equation of the for the path of a particle moving under central force? Equation um, for path of the particle moving under central force, and that equation is del square u by del theta square plus u is equal to minus m f of r divided by L square U square. Here U is the function of R, that is U is equal to 1 by R, that is and F of R is the force. We have to find out the force of proportionality with R. Okay, so let us put the values of U. So U is equal to 1 by R, so U will be 1 by e to power minus alpha theta d to alpha theta. Put the values, that will be alpha square e to power alpha theta plus e to power alpha theta is equal to minus m f of r divided by L square U square. So if you do the thing, that will be alpha square plus 1 e to power alpha theta, and U square here will come in multiplication, and L square minus m f of r. So then all the things are constant. So if you see, the f of r is equal to is proportional to u square e to alpha theta, and u square is u is equal to e to alpha theta, so that will be e to alpha theta is u, so that will be uq. That implies f of r is proportional to 1 by rq. Okay, and that is the option C. Okay, let's go to the next question, and the next question is, for a system of unit mass, the dynamical variable follows the relation. Dynamical variable. Okay. Where x is the position of the system at time t and x naught is initial position, what is the force acting on the system? Here, see, the only concept here is the Lagrangian, because the dynamical variable is given, and the position coordinate and velocity coordinate is here. So do you think how we get force from the Lagrangian equation, that is del L by del x dot, where x is the if we take in with respect to x, then del by del t minus del L by del x equal to 0, and you know that del L by del x dot is equal to px, that is the conjugate momentum. So that will be del by del t of px is equal to del L by del x. Del by del p, derivative of momentum with respect to t is the force. So force will be del L by del x, and here L is equal to, if you here x dot square is given, that means velocity square. So L will be half m x dot square. Okay, and here a dynamical variable, that means it's moving, and there is no things about potential, so I'm taking as only the kinetic energy. So that will be L will be half m x dot square, values put here, that k x naught square plus x dot square x naught dot square minus k x square. So do the derivative, that will be half m into minus k into 2x, so that will be minus m kx, but here the unit mass is given, so that will be minus kx. That implies force will be minus kx, as you see in option A. Okay, let's go to the next question. Here the next question is the front end of a train moving with constant acceleration. Okay, suppose the train is here like this. Okay, front end of a train moving with constant acceleration, and the pole is here. Suppose passes a pole with velocity u, the front end moving with velocity u, and the back end passes the pole with velocity v. See, the train when passes the pole, that velocity will be v. Then what is the velocity of the midpoint, this point, when it passes the pole? If the length of the train is L, I'm taking, then when a pole passes the midpoint, then its length will be L by 2. Okay, if we um, uh, do this equation, that u square is equal to v square is equal to u square plus 2as. So this is the relation between the initial velocity and final velocity, and when the length will covered by, that is displacement will covered by L. Okay, so v square minus u square divided by 12 is equal to a. A is the constant acceleration that will be remain same for all point of the train. So then when that train passes the pole, uh, midpoint of the train passes the pole, so the velocity is equal to Vm square is equal to u square plus 2as. Here the displacement is equal to L by 2. Okay, so Vm square is equal to u square plus, put the values of a, that is v square minus u square divided by 2L into acceleration is L by 2, that is cancel out, and here also 2 multiply, so 2 to cancel, that implies Vm will be u square plus v square divided by 2 whole root. Okay, that is the answer. Okay, let's go to the next question. This is the last one question. Okay, the Lagrangian of the particle, unit mass particle is given. Okay, then we have to find the Hamiltonian. As you know, the Hamiltonian we can find by a sum of p q dot minus L. So this is easy question. See, h is equal to sum here only the x term, so px x dot minus L, and you know the phi x is equal to del L by del x dot, so that will be x dot plus 2x, and put the values, so x is equal to px x dot minus L will be half x dot square plus half x square minus x dot. Okay, so put the value of px, that will be x dot square plus 2x x dot minus half x dot square plus half x square minus x dot. See, something will be 2x dot, so things will be like this. I think I made some mistake somewhere. Okay, here 2 is not coming because half get cancel, only x remain, so x dot get cancelled, and if we differentiate it, that will be half x dot square plus half x square. So put the values of x dot, because Hamiltonian is the function of position and momentum only, so x dot will be px minus x, so put half px minus x square plus half x square. If we expand this, the term will be px square by 2 minus px plus x square, and that is the answer. And all the things I have already explained. So thank you. Keep watching, keep learning.